Suppose the number of visitors arriving at a zoo can be modeled to a Poisson distribution. On an average, 20 visitors arrive per hour. Let X be the number of visitors arriving from 2 p.m. to 4 p.m. Then the probability that at least 35 visitors will arrive in the given duration is. So lambda for basically 1 hour, lambda is basically the average. Lambda is given as 20 visitors per hour. But because we have been asked the question that uh, let our random variable, let x be the number of visitors arriving from 2 p.m. to 4 p.m. So here the time span is 2 hours. So our new lambda, which is new average, will be 40. So 40 visitors arrive per 2 hours. All right. Now, at least we have to find the probability that at least 35 visitors arrive. Now, let's say, what is the probability that exactly 35 visitors arrive? Then it will be uh, defined as, so this is the formula of the uh, Poisson distribution, all right, that exactly 35 visitors arrive. But we have the we have to find the probability that at least 35 visitors arrive, and that will be probability of having 35 visitors plus or 36 and so on to infinity. Now this will be summation of now, and it is from basically 35. We are starting from 35 to infinity, and this is x. So this will be our answer. This will be the probability that at least 35 visitors will arrive in the given duration. If we were asked the question that at most 35 visitors will arrive, then what we will do is we will find the probability, then the total probability will be, Px is equal to 0 and so on to, and this come out to be x. So this is the probability that at most 35 visitors arrives in 2 hours, and this is the probability that at least 35 visitors arrive. Suppose the probability that any given person will independently believe a tale about the existence of a parallel universe is 0.6. So let A be the event that a person believe uh, believe the tale, and its probability is given as 0.6. Now what is the probability that eighth person to hear about this tale, about this existence of a parallel universe, is the fifth person to believe it? Now what do we want is, out of the out of the first seven to hear about this, we want exactly 4% to believe it. Alright, so that's the first thing. And so it is a binomial distribution. So out of the seven, we want 4% to believe the tale, and the probability of believing is 0.6. So okay, so with this probability, out of the seven, 4% believes the tale. Now the second thing is we want is eighth person believes the tale, and the probability we have already know that uh, PA is 0.6. All right. So now let's say this event is uh, event X, and this is uh, event Y, that the eighth person believe it. Now X union Y is basically, and because that any given person will independently believe a tale, this will be 7C4 into zero point 0.6. So this will be our answer. Remember that whenever you deal with finding probabilities, always define events first. A fruit owner sells fruit in a lot that contains 50 fruits. Alright. A customer selects 5 fruits at random from a lot and rejects the lot if one of the 5 selected fruits is rotten. What is the probability that the customer will purchase the lot if there are 4 rotten fruits in the lot? So what do we have? So so there are 50 fruits in the lot. So the fruit owner has 50 fruits. And there are 46 fresh fruits, and there are 4 rotten, and there are 46 fresh fruits. So a customer comes and he selects 5 fruits at random, and if he finds even one fruit that is rotten in it, he will not purchase. So we have to find the probability that the customer will purchase, or we have to find that a customer chooses 5 fruits and all are the fresh fruits. All right. So let's say what is the total outcome? Total ways in which 5 fruits can be selected, which is 50C5. And what is our favorable outcomes? Favorable outcome is that all the fruits are selected from the fresh fruits. So 46C5. Now the probability is simply that 46C5 upon divided by 50C5. That is all. Because we have to select the favorable outcomes will be that all the 5 fruits selected will come from the fresh fruits. Next question is, suppose that in the end semester paper of statistics, there are 18 multiple choice questions and only one option is correct for each question. Each question has 4 possible options. You know the answer to 8 questions, but you have no idea about the other 10 questions. Choose answers randomly and independently. Your score X of the exam is total number of correct answers. Find the value of that that the correct answers are equal or greater than 12, or that there are at least 12 correct answers. So we know answer to 8 questions, all right? So the probability that we answer 8 questions is 1. Now the each question has 4 possible answers. So we will be guessing for the rest of the 10 questions. So the probability of that we choose the right options is let's say is zero point 0.5. All right. So we have to find the probability that we answer at least 12. All right. So this is a binomial distribution. All right. So we have 8 questions. 8 questions we know the answer. So out of the 12, uh, there are 18. Sorry, there are 18 questions, and we know the answer of 8. So out of the 10 questions, what we need is we need and let's say P Q. All right. So we need to find out of the 10 questions, we want exactly we want 4 or more correct. All right. So this will be C5 up to 10. And it starts from 4 to 10, and it will be 10CX. So this will be the probability for at least we have 12 answers correct, and P here is 0.25 and Q here is 0.75, and actually uh, this will be 4. Just a second. Yeah, this will be 4 and this will be 6, and this will be 5 and 5 and so on, and this here will be 0 and 10. So in this formula uh, we need to correct it actually. Just a second. Yeah, the correct formula will be we start from 4 up to 10, and 10CX and P to the power X and Q to the power 10 minus X. So this can also be written as the probability is equal to 1 minus 0 to 3, and 10CX. So both will give the same answer. And there is one more correction here, because out of 10 we want only 4 and more correct, so we will do 4 here. All right, because we know the answer of 8 already. Next question is, एक शॉपकीपर मोबाइल फोन सेल करता है, एंड जो डिमांड है मोबाइल फोन्स की, इट फॉलोज द पॉइसन डिस्ट्रीब्यूशन विद मीन 4.6. so lambda is given as 4.6 per week, of course. Okay. Now इस एक शॉपकीपर के पास 5 मोबाइल फोन्स हैं उसकी शॉप में at the beginning of a week. Find the probability that this will not be enough to satisfy the demand for mobile phones in that week. So what we have to do is what is the probability that the demand will be more than 5 phones, because if the demand is more than 5 phones, then then having 5 mobile phones will not be enough. All right. So this can be written as uh, 6 to infinity, and then we have lambda, which is 4.6. So e minus 4.6, 4.6 to the power x factorial. All right. But this same thing can be written as 1 minus, we can start from 0 to 5, and e to the power minus 4.6, 4.6 to the power x factorial. So this will be the probability that the demand will be greater than 5 phones. All right, let's see this question now. So x be a discrete random variable with the following probability mass function. So this is the mass function we have, and then y is a function on the discrete random variable that we have, and it is defined by this expression. All right. So first of all, what is the range of x? X is a discrete random variable, so x can take the value 0, as you can see here, 0, 1, 2, 3. All right. And the probability of x is given as, for 0 is 0.2, zero point 0.3 for 1, zero point 0.4 for 2, and zero point 0.1 for 3. All right. Now we can consider y as a discrete random variable itself. So y. So if x is 0, y come out to be 3. All right. If we put 0 uh, in the place of x, y is 3. All right. And if x is 1, then y is 0, and accordingly. So these are the values that we have of y. All right. So y is a random variable, and it is a function on the discrete random variable x. Now we have to find the probability that y is less than or equal to 32. All right. So less than 32. So these values of y satisfy our the probability that we want to find. These are the cases that we need, and as you can see, these are the probabilities. These are the sum of the probabilities that we require. So, and the answer is 0.9. Let's see this question. So I roll two fair sided two fair six-sided dice and observe two outcomes. Let the random variables y and z denote the outcomes observed on the two dice. All right. So the outcomes of the first die are denoted by random variable y, and the outcome of the second die is denoted by the random variable z. And x is a function on these random variables, and x is equal to y plus z. So find the probability that y is equal to 3 given x is equal to 6. So first of all, y is equal to 3 given x is equal to 6. This is uh, this is denoted by probability of y is equal to 3 union x x is equal to 6 divided by probability of x is equal to 6. Remember that x here is the sum of the numbers on the dice. So probability of y is equal to 3 and x is equal to 6. There can be only one case of this, which is the number 3 3. All right. Only this outcome will satisfy it. So there is only one outcome, and divided by x is equal to 6. So how many outcomes will satisfy this? So there will be 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. The sum of all these numbers is 6. So total outcomes come out to be 5. And this is the probability that given the sum is 6 of the two dice, is what is the probability that y is equal to 3. Alright, take a look at this question. Take a coin 50, toss a coin 50 times and let the random variable x be defined as the number of tails observed. Find the average of the values in the range of the random variable. So x is a random variable, and what will be its range? The range will be 0, 1, 2, up to 50. Alright. So what will be the average? Average is sum of values and total values. So the sum of the values from 1 to 50 is given by the formula 50 into 51 by 2, and total values are from 0 to 51 are 51. So this gives us 50 upon 2, which is 25.